Good afternoon. My name is Mehul Shah, and I'm the General Manager of AWS Glue and AWS Lake Formation. Today, I'll be talking about data security and data sharing in AWS Lake Formation. I'll talk about how we do it and some of the new use cases that it enables and some of the new opportunities that we have as a community to go solve some interesting problems. Before I start, let me first motivate what a data lake is and why people are moving to data lake architectures. Then I'll describe how data security and data sharing is implemented or done in lake formation. And then I'll talk a little bit about some of the use cases and some of the open questions that arise. So if we look back about 30 years ago, enterprises actually put all the information in their organization into a big information hub called an enterprise data warehouse. They would take all of the structured information they had in their operational database systems, go through a centralized ETL process, unify all that data, and then ask questions over that data, typically using SQL and a bunch of reporting tools and ad hoc BI tools. And this is how they would analyze how well the business was doing and how to optimize that business. But unfortunately, there are three trends that are actually pushing them away from enterprise data warehouse-like architectures. The first one is that the data that they want to analyze no longer fits inside of a data warehouse. It's too large to be cost effective in a data warehouse, and it's also much more diverse. They have unstructured data, they have semi-structured log data, network feeds, social networking feeds, IoT streams that they want to analyze. And it's just not cost effective in a data warehouse. And if you take a look at our customer base, across our customer base, companies are actually storing, and the amount that they're storing is growing about 10x every 5 years. And so if they're going to move to a new data platform, they need to be thinking about 3 orders of magnitude increase in scale, from petabytes to exabytes. The other thing that's happening is that the people that want to analyze this data are changing. It's no longer just business analysts or business users. You have data scientists, you have DevOps people, you have application developers, all want to analyze their data, and they want to do different types of analyses. It's not just, again, SQL analytics. It's scientific analyses, machine learning, real-time streaming analyses, and basically data warehouses just can't keep up with all the kinds of things that people want to do. And also in the last decade, we've seen increased regulatory pressure on how you can use and share the data that you have in your organization. And so while customers and our enterprises want to democratize access to the data within their organization, there's this sort of tension with these regulations, whether they be government regulations like privacy regulations like GDPR or CCPA, or industry regulations like HIPAA, or just regulations that they have or governance requirements that they have within their organization. And so instead of building data warehouses, they're still centralizing all their information into a thing called a data lake. It's the new information hub. It's a centralized secure repository that enables you to govern, discover, share, and analyze the structured and unstructured data that you have at any scale. And the way it's different from a data warehouse is they're no longer storing it into a database system. They're storing all this data into a large object store. In our case, it's Amazon S3. We see our customers taking on-premises data, real-time streaming data, and just pouring it into S3 because it's ubiquitous, it is extremely cheap, and highly durable or reliable with 11 nines of durability. And then the cloud allows them to then take that data and bring it in to a variety of different analytics engines very quickly and efficiently and on demand, right? So while data warehouses are still useful here, Amazon Redshift is our data warehousing service, other analytics engines are now starting to become more and more used. For example, SageMaker is our ML service, EMR is our big data service, and so on and so forth. And what they need is a single locus of control to multiplex this data across all of these engines, multiplex it securely and efficiently. Today, we have more customers and more data lakes on AWS than anywhere else. I think the running count is over tens of thousands of data lakes on AWS. And so this central locus of control is what Lake Formation is. It's a fully managed service that enables data engineers, data stewards, and data analysts to build clean, secure data lakes in days. Here's some of the customers that are actually using Lake Formation in production. We launched it a year ago. And the typical steps of building a data lake, you might be familiar with. You've got to load your data into your data lake, ingest it and clean it. We know about this, right? We know this is a hard problem. There are a lot of people working on it. But securing your data lake is just as hard. And we find that our customers are spending just as much time trying to figure out how to set up security policies across all of the various engines and services, taking almost as much time as maintaining their data lakes. And these things are getting pretty complex. And this is what I want to kind of focus in on this talk today. So how does Lake Formation work? Well, it's pretty simple. We take a database-like model for your data lake. Administrators basically set up users and permissions on their data lake resources, which are modeled inside of a data catalog. Data catalog models the data as databases, tables, and columns. The tables are semi-structured tables. They have fields in them. And then you can specify access controls just like you would in a database with grants and revokes on the resources in your data catalog, which represent objects or collections of objects sitting on S3. And that's really the security component of Lake Formation. Lake Formation now also has other interesting components like ingest and cleaning components. We're not going to talk about them today. Then when a user wants to access that data through one of these integrated services, they consult Lake Formation, get information about the metadata to see what fields and tables that user has access to. And then those engines will then run the queries that the user asks after it's been authorized. The nice thing about Lake Formation compared to other systems is that we're borrowing all of these ideas from the database world and applying it to the data lake world. And the idea of providing fine-grained permissions on databases, tables down to the column level is unique and is actually quite useful. Instead, what people were doing before is trying to make copies of their S3 buckets and objects in their S3 buckets that basically comprise your tables to get the fine-grained access control or the fine-grained hiding that they wanted. And it was really cumbersome, cost a lot of copies and time. The nice thing about the database model is that it's actually perfect for these use cases because you get to delegate access. You can say, hey, I've given user one access to some subset of columns from this table. These are the columns at the bottom. User two has access to some subset of columns. These are the columns at the top, and you can pick any permutations of columns. And then I can also give these users permissions to further delegate access to these columns and other tables and so on. So this delegation is extremely powerful. It's really what's going to enable our sharing. And the other thing that we do in the database world is we actually combine these grants and these permissions that are given to us into a unified permission set that allows us to get the union of all the results that we have. This is really nice compared to sort of managing policies and creating policies on the fly all the time. And then finally, because Lake Formation is centralized in terms of its API access, you can audit all the permissions in your data lake in a single place and all of the data access used in a single place, which is useful for compliance. Here's how it works. In Lake Formation, you submit a query. User submits a query for some table T. The integrated services request access to that table to Lake Formation. Lake Formation consults and then decides whether that user has access to that table and which components of the table that user has access to. The user has no idea, by the way, that there are any extra columns in that table if it's not exposed to them. Then Lake Formation returns short-term credentials to these integrated services. These integrated services are trusted services by AWS, and so they will then go to Amazon S3 and retrieve the objects that comprise this table. These are just S3 objects, using those short-term credentials, and then apply the filters that are necessary, and then run the queries that the users are asking for. So the filtering is actually happening inside the service itself. We have a customer new skin that's using this to hide PII data. It's a healthcare company. And what they want to do is they want to share their data with their customers, manufacturer and revenue forecasts. But they don't want PII information leaking. And previously, what they were doing was making many copies of their data, maintaining ETL processes to maintain those copies. And they were able to reduce their storage costs by 43% and their ETL costs by 37% using lake formation. The same delegation model that we have in databases applied for data lakes and lake formation, we're going to use that to actually share data across accounts. So producer, sort of, you imagine if you had an account that was a producer account that actually stored your data lake and it wanted to share that data lake with another account. We're going to simply do a grant to another account, just like we grant to users. And then the delegation model just kind of keeps going. Consumer accounts can then have admins come in and delegate access to various shares to their users. Shares are resources like databases and tables and columns. Consumers accounts can also soft link those shared resources inside their data catalog, just like you would do a soft link to a file in the file system. So any engine or application that's actually running inside of the consumer account can access these resources as if they were local to that account. They wouldn't know any different. And then once you're allowed to actually share this kind of data from one data lake to another, without ever actually moving the data, these are just, again, for references all inside of lake formation, and the data is filtered on demand, you can now enable a whole bunch of data lake sharing topologies. We see our customers doing a variety of these things. You have the standard central hub and spoke topology, where customers will come in and have a single data lake, centralized data lake that is then shared across a bunch of accounts in their organization. You have supplier sort of vendor topology across companies we see, where companies will vend access to some data that they want to share to a distributor, for example, like Amazon, which is a retailer. And then we're also seeing companies actually set up sort of ad hoc networks of sharing. As people come in and share their data sets with others, you can actually get these sort of peer-to-peer relationships set up. And I think there are other companies that have done this just inside their own organizations, and they call this a data mesh. So this is starting to emerge. A simple application of the cross-account sharing that you can see of lake formation is the public COVID-19 data lake that we launched at the beginning of the year. We actually wanted to put all of the public information to help researchers and public health officials trying to track the COVID-19 pandemic and all of the related data sets that are there. So we have structured data sets on deaths and cases, hospital bed availability. We have unstructured data on research articles, on predictions that people have and where things will flare up. And you can use a variety of engines. So our customers are actually doing this to go and track and contain the virus. In some cases, they're trying to do it. Food manufacturing companies are doing it. Nonprofits are doing it. And they're using various engines like Athena and QuickSight for doing just simple analytics. They're using ML services like Comprehend Medical and Kendra to do searches. And they're actually going back and forth, because what Comprehend Medical can do is generate tags, for example, interesting tags that are inside your research data sets, which can then be collected and collated in Athena. And then you can query relevant research articles that you need. Then there's a whole bunch of open questions that this actually enables. Like, what happens when we want to share not just individual records and individual databases, but what happens if you want to actually share aggregations of your data so that so you can actually make statistical statements about what you have without actually violating privacy. How do we actually talk about that, especially in a context like a data lake? Other questions that arise are, when you want to do public data lake, how do you assure people that the data that you have is publicly available, or that it came from a source that actually gave you the rights and the licenses to access that data? And then finally, if you're going to set up these topologies in a variety of different ways, especially in a data mesh, how are you going to find the data that you're looking for? And how are you going to know how to subscribe to that data and what the licensing terms are and how it can be used? So doing this actually shares up a brand new data economy. I'd love to collaborate and talk to you about, some of the interesting problems that we're working on today. And hopefully as a community, we can go solve some of these things in the upcoming decade. Thank you so much. And would love to, get your comments.